Now let's just move on further towards the another graphical representation of the data, which is nothing but called as the histogram. So what is actually a histogram? So it is a form of a representation like the bar graph, but it is used for the continuous class intervals. Means in this we have the continuous class intervals like 0 to 10, 10 to 20, and so goes on. So let's just see an example which is related with it. It says consider the frequency distribution table representing the weights of the 36 students of a class. So this is actually the representation. Now you can see over here we have the class intervals which is given to us as 30.5 to 35.5, 35.5 to 40.5, 40.5 to 45.5, and so goes on. These are the continuous class intervals that are given to us, and we have to draw or form a histogram for this particular representation of data. So just like the case that we already have done with the bar graphs, in which we have taken some of the steps that are all related with how we can construct the bar graph, we also have some of the steps that are all related with the histogram. That if we are going to represent the histogram, then first of all on the x-axis we'll represent the weights. As you can see over here we have the weights, which are nothing but the continuous class intervals. So the continuous class intervals will be on the x-axis. The number of the students, which is nothing but the frequency, would be on the y-axis. So let's just see the steps which are related with it. So the step number 1 would be like represent the weights on the horizontal axis choosing the scale 1 centimeter is equal to 5 kg. We start with a kink. We'll start with a kink over here. Why so? Because we know that the intervals are actually starting from 30.5. So we just have to take a kink in between the point 0 to 30.5. This is the step number 1. Step number 2 would be like we have to take the number of the students representation on the vertical axis, and then we have to draw the rectangle or the rectangular bars with the width being equal to the class size and the length which is according to the frequency of the corresponding class intervals. So let's just see how we can form the histogram. So first of all, I have just taken the weights over here and the number of the students over here. This is nothing but the frequency, and I have also taken a kink over here because we know that we have a 0 and then we have the number as 30.5. So we are just taking a kink over here. So let's just talk one by one about that. In between 30.5 to 35.5 we can construct a rectangular bar which is nothing but of this type, having the frequency as 9. Since we are just talking about the continuous class interval, it means that we do not have any gap in between the rectangular bars, just like the gap we have in the bar graph. So if I'm just talking about the next class interval, that is 35.5 to 40.5, then the rectangular bar that would be formed over here would be nothing but this, having the frequency as nothing but 6. Now they are combined together. There is no gap in between, just like that of the bar graph. Now let us suppose if I'm continuing further for 40.5 to 45.5, having the frequency 15, further we have the frequency as 3, further we have the frequency as 1. So this is actually if I'm just talking about the further one, this do have a frequency as 2. So this is nothing but a type of the representation of the data, which is nothing but called as a histogram. This is called as the histogram, and you can observe over here that there are no gaps in between the consecutive rectangles, or the resultant graph appears to be a solid graph. So what can we say about a histogram? A histogram is actually a representation of the grouped frequency distribution with the continuous classes. As you can see all by yourself, if you can easily differentiate in between a bar graph and a histogram, that what is a bar graph and what is a histogram. And you can see over here that it is actually a representation of a grouped frequency distribution with the continuous classes. And there exists a very special node which is related with this histogram. What is that node? The node says the area of the rectangles, means the rectangular bars that are actually we are forming up over here, their areas should always be proportional to the corresponding frequencies. What does it mean? If I'm just talking about the area of the rectangular bar, let us suppose if I'm just taking this rectangular bar having the frequency as 9. So as you can see, if I'm just talking about its width, so I'm taking its width as nothing but 5, and its height is definitely 9. So we have the length as 9, we have the breadth as nothing but 5, because we know that their class size is 5. So obviously if I'm just taking its area, so area would be length into breadth. So whatever we are getting is actually proportional to that of the corresponding frequency. So hence this is a very special note which is related with the histogram. Always remember that the area of the rectangles that we are actually erecting over here or we are forming up over here, they are proportional to the corresponding frequencies. However, since the width of the rectangles over here are all equal, the lengths of the rectangles are proportional to the frequencies. So the lengths are actually proportional to the frequencies over here because of the reason that their width of the rectangles are all equal to each other. So this is the case when we have the width being equal to each other, but we also have a histogram in which the width should not be equal to each other. So what can we do for such type of a histogram? So let's just take an example for that one. Let us suppose if I'm just talking about this particular example in which we have a teacher wanted to analyze the performance of the two section of the students in a mathematics test of the 100 marks. So this is the type of the question that we have. Now you can see over here, if I'm just talking about 0 to 20, 20 to 30, 30 to 40, so the class size of the very first class interval, that is 0 to 20, is nothing but 20, but the class size of 20 to 30 is nothing but 10, and further we have 10, 10, 10 and 10, but for this one we have 20, and for this one means 70 to above we have a different width. So here we can see that for this particular histogram, if I'll just form it into the formation of a histogram, then they definitely have the different widths. Now let us suppose if I'm just drawing a histogram for this one. So as we know that from 0 to 20 we have the frequency as nothing but 7, from 20 to 30 we have this, from 30 to 40 we have this, from 40 to 50 was this, from 50 to 60 is this, from 60 to 70 is this, and from 70 to 100, the question says 70 to above, but we know that the total students was 100, so we are just taking 70 to 100, their frequency is nothing but 8. Now you can see over here, if I'm just talking about such a type of representation, then we definitely can say that this representation is actually misleading information. This is misleading interpretation. Why so? Because from the previous example, we definitely know that the areas of these rectangular bars are actually proportional to their corresponding frequencies, and in the previous section we also have done that the width of the rectangular bar should always be equal to each other, but over here we can see that the width they are not equal to each other at all. They are not equal to each other at all. So it means that we just have to modify this interpretation in a more meaningful manner. So let's just see how we can modify this particular histogram. So it implies we need to make certain modification in the lengths of the rectangle so that the areas are proportional to the frequency, because this is a very special note in the histogram. Always remember the area should be proportional to the frequency. So in the previous histogram this condition wasn't satisfied at all. So now we are going to satisfy this condition. So let's just see how we can do it. There are some steps which are related with it. First of all, we have to select a class interval with the minimum class size, and for this example the minimum class size was nothing but 10, and then the length of the rectangles are then modified to be proportionate to the class size 10. So we then again make the length of the rectangles in such a way that they should be proportionate to the class size 10. Now let's just see how we can do this. So first of all, we have the marks as this, we have the frequency as this, we have the width as this. So we are actually modifying the length of the bars. So the length of the rectangle should be nothing but of the form. We are just taking a ratio over here which is nothing but frequency by the width into 10. 10 was nothing but the lower class size or the lowest class size that we have in all the class intervals that we have. So we are just taking the ratio as 7 by 20 into 10, which is 3.5. For the 10 by 10, this is frequency by width, 10 by 10 into 10, which is 10, 10 by 10 into 10, which is 10, 20 by 10 into 10, which is 20, 20 by 10 into 10, which is 20 again, 15 by 10 into 10, which is 15 again, and 8 by 30 into 10, which is nothing but 2.67. And now if I'm just looking at this particular interpretation, then I can see that the areas of the rectangles are actually coming proportionate to that of the corresponding frequencies. Now let's just form the histogram. So always remember, whenever we have such type of the histograms which are providing us some misleading information, then we can transform it or we can modify them into such a formation. Now let's just form a histogram for this one. So these are the marks, these are the students that we have. So now let's just see how we can form it. So from 0 to 20, now we have the size, or we can say the length, as nothing but 3.5. The length is now reduced, now it is nothing but 3.5. Now further from 20 to 30 we have a reduced length, and further you can see this is the way that we have formed a new modified histogram, which is actually do definitely have of the varying width, but in this particular histogram we do have a correct information, and the condition also satisfies over here that the area of the rectangles, they are actually coming proportionate to that of their corresponding frequencies. So this is the way that how we can deal with two different kind of the histograms.